In both sections of Math 115 today, neither group that was assigned number 42 had quite enough time to finish. So what I wanted to do was put that example up here so that you could have a second example of back solving to find x and y in terms of z. So we're going to join this problem in progress. So the first thing I did was decide to eliminate the x's from each of these problems. And once I eliminated the x's by adding row 1 and row 3 and row 2 to 3 times row 3, I had 4y plus 4z equals negative 4 and 8y plus 8z equals negative 8. So then, now that I've got a two-variable system, I went ahead and solved that two-variable system by multiplying the 4y plus 4z equals negative 4 by negative 2. That gave me negative 8y minus 8z equals 8. And when I added that to the second equation, I got 0 equals 0. This told me I was in the infinite solution case, and so for my answer is going to look something like this. It's going to be an ordered triple, and I have to let one variable be a parameter. I'll choose z in this case. And now I'm going to go back and I'm going to pick one of the equations. I'll pick 4y plus 4z equals negative 4, and 4y plus 4z equals negative 4. If I solve that for y, I'd get 4y is equal to negative 4z minus 4, and if I divide everything in sight by 4, I get y equals negative z minus 1, and so I can put z minus 1 in place of y. And now I need to go get another equation so that I can get x. And if I go to the original problem, x plus 2y plus z equals 0. Could have picked any of them, but this seemed like the one that would have the least amount of arithmetic and algebra. So I want to get x in terms of z, so the first thing I can do is take what I found y to be, and I just fixed a mistake I had before. I think we had y equal to negative z minus 1 a minute ago. And so I'll put the negative z minus 1 plus the z is equal to 0. So x minus 2z minus 2 plus z is equal to 0, or x minus 1z minus 2 is equal to 0. If I add z and add 2 to both sides, I can then write z plus 2 for the x variable. Now I've got x and y solved in terms of z. There's infinitely many solutions, and this is what I would record on the answer line if I were asked to solve that system of equations.